Hello, welcome back to JD Science Prep. Today we are discussing some more stoichiometry problems. So in a previous video, we had a little introduction to stoichiometry, what it's used for, as well as a flow chart you can use to solve some of these problems. And we went over a pretty simple question. So if you want to refer back to that one, go ahead. But as for this one, we have two questions to review today. We're going to be using that flow chart as well. So let's actually, let's get into this. So for number one, it says for the reaction between sodium hydroxide and sulfuric acid, if we have a mass of 3.4 grams of sodium hydroxide, how many moles of sulfuric acid would be needed to fully react with the sodium hydroxide? So the first thing to do with these stoichiometric problems is actually to balance this reaction. So we have the reaction between sodium hydroxide and sulfuric acid here, and why don't we go ahead and balance that? So if you have issues balancing reactions, go and check out my video on that if you're unsure. If not, this should make sense to you. So we have our reaction all balanced up. The next part is we are going to figure out what we have and what we are trying to get from this question. So we are given a mass of 3.4 grams of sodium hydroxide, and it's asking for moles of sulfuric acid. Okay, so we are going from mass of sodium hydroxide to moles of sulfuric acid. So sulfuric acid, so we have H2SO4. Now with that, we can actually bring this over to our roadmap and figure out where our where our question's going to take us here. So again, we can say that NaOH is our A substance. So we're beginning at mass of A, and we are going to moles of sulfuric acid, which is our B substance. So we must go from mass of A to moles of A to moles of B. That is our conversion. Okay, so we're going to be doing two different calculations here. So let's go ahead and do that. So we are going to start off with what we know. We know 3.4 grams of sodium hydroxide. Now, before we can go to moles of sulfuric acid, we must get to moles of sodium hydroxide. Okay, so we want on the top the unit that we would like. So we want moles of NaOH, and we must divide by NaOH's molar mass. So we can go ahead and put that in. So 40 grams of NaOH. Also, if you're having troubles calculating molar mass, go and check out my video on that as well. So if we were to stop right here, we would be in moles of NaOH, but we do not want that. We want to get to moles of sulfuric acid. Okay, so the only time you're going to be using the coefficients in the balanced formula is when you are going from moles of A to moles of B, and that is what we're doing right now. So on the top, we want moles of sulfuric acid, so we will put 1 mole of H2SO4 on top. We got this 1 from our balanced formula. Okay, I want to make that very clear. And on the bottom, we are getting rid of moles of NaOH. And from our balanced formula, or our balanced reaction, we have 2 moles of NaOH. Okay, and again, our units do cross off. Our moles of NaOH cross off, and we're left with moles of sulfuric acid. So according to the question, that's what it wants us to figure out. So we are going to stop at that step and type this into our calculator. So I'm going to go 3.4 grams of NaOH divided by 40.00 grams of NaOH, and divide that by 2. Okay, and what you should get here is 0.0425, and we're going to round that to 0.043 moles of H2SO4. That's going to be our final answer with significant figures. That looks fantastic to me. Let's move on to number 2. So it says, for the reaction between zinc and hydrochloric acid, if we have 3.2 grams of zinc fully reacting, what volume of hydrogen will be produced? Okay, so again, let's go ahead and balance this reaction really quickly here. So we'll put a 1, try 2, a 1, and a 1 again. That looks like it's all balanced. Perfect. So let's figure out what we are trying to get. First off, we have 3.2 grams of zinc, and we are looking for volume of hydrogen. Okay, so let's refer to our moles flow chart, our stoichiometric flow chart really quick. So we are starting with, I'm just going to erase from last question. We are starting with, again, mass of A. Since we are starting with zinc, zinc will be our A substance, and we are going to volume of B. Okay, since hydrogen is our B substance, we're going to hydrogen. So we have 1, 2, 3 steps to complete before we can find volume of hydrogen. If you need to pause the video and read what steps we're going to be taking, you can go ahead and do that, but we will begin. Okay, so we'll start off with our 3.2 grams of zinc, and our first step is to get to moles of zinc. So I want on top moles of zinc, and I'm dividing by the molar mass of zinc, which is going to be 65.39 grams of zinc. So if I was to stop right there, I would be in moles of zinc, but we're not quite done. So next step, we are going from moles of A to moles of B. We are going to be using our coefficients from our balanced reaction. It looks like we just have a 1-to-1 ratio, which is okay. When you get more advanced, you'll realize that you can skip this step if you have a 1-to-1 ratio, but sometimes it's just it's easier to include all the steps. Now finally, we are now in moles of H2. We can go to volume of H2 by multiplying by that gas constant of 22.4 liters of H2. And on the bottom, remember, we are getting rid of moles of H2. Okay. So we have all of our steps down. Our units look good. We're in liters of H2. We can go ahead and type that into our calculator. So we're going to go 3.2 divided by 65.39. And we can kind of skip this step since it's a 1-to-1 ratio. If it was any numbers other than, I guess, a 1 and a 1 or a 2 and a 2 and or a 3 and a 3, you would have to type it into your calculator, but it's an even ratio. So now this last step, we are going to multiply by 22.4, and what you are going to get is 1.096. And why don't we round that to 1.1 liters of H2. Okay. So those are our examples that we went through today. I hope this has helped. If it has, please like and subscribe. Thank you very much.